Hello friends, these are a few switching power supply boards. On this switching power supply board, we can see there is a heat sink. There are two heat sinks on a board like this one. Here is a heat sink. This is one piece. Like this one on the switching power supply, there is no heat sink in this area. Where is its heat sink? It is integrated with the case. It is using this case for heat dissipation. In other words, these components are connected to the housing. But between them and the case, there is an insulating sheet here. No direct contact. As for this board, right here, it has its own larger heat sink. So in these videos, let us take a look at this heat sink. After we power it up, can we touch it with our hands? Hey, will it electrocute us? First, let us look at this smaller switching power supply board. On this switching power supply board, since it is connected to the case as one piece, so that means the heat dissipates through this housing. What happens when we touch this housing? There's definitely no risk of electric shock. Why is that? Let's look at this area. We can see it's separated from the housing by an insulating material. So there's no issue with this design at all. Let's take a look at this other type. This one uses a larger heat sink here. This heat sink, if we look at the back, we can see it's a switching transistor. Let's examine this heat sink again. How is it attached to this board? Here it is. It uses 3 screws. One here, and one here. What about these 3 screws? They're not on any of the circuit traces. So when we touch it, there's no risk of electric shock. Additionally, we need to check this component on the transistor. Is its back connected to these 3 legs here? Generally speaking, the center position is connected to the back. But we can see this part. There's no connection between its center and back. Because the back is just this plastic. It doesn't have this cooling metal sheet. Now let's take a look at this larger switching power supply board. This is a heat sink. In this position, we can see this is one of its connection points. Here are the 2 contacts. It's also one of its fixed feet. We can see that these 3 pins are all fine. Hey, but what about this line here? We can see where it goes. It follows this path to reach here. When it gets here, let's look at this position. It's a ground wire for the switching power supply. We can see it reaches right here. It reaches this large filter capacitor here. So this pin is connected to this pin. This means that the heat sink is connected to the hot ground. So when we touch it, there's a risk of electric shock. The voltage is very high. After going through the PFC, the voltage reaches over 380 volts. This voltage is extremely high. We'll measure it later. We'll take some actual measurements to show you. Now let's look at this heat sink. This heat sink, we can clearly see that there's a division at this point. The left side is cold ground. The right side is hot ground. Cold ground just means relatively lower voltage, but we'll need to check the actual output voltage. Generally speaking, for this power supply board, the output voltages are 48 volts and 12 volts. Of course, when a person touches it, the risk is relatively low. Let's look at how this heat sink is attached at the back. This heat sink, these 2 pins, they're connected to one piece. That's not a problem. But here, we can see that. It's the same as this hot point. So it's connected to the cold ground here. This means the heat sink and the negative terminal of this capacitor here are connected together. Let's take some measurements to verify. So it's continuous. We can touch this cold ground. Usually the voltage is relatively low. It's almost harmless to the human body. But this hot point, we're going to measure its voltage. Let's power it up and see what the actual voltage is. We can see the voltage displayed on the multimeter. It's a little over 380 volts. As for this switching transistor heat sink, sometimes it's connected to this hot point. This part is not to be touched. For the cold ground area, if the relative voltage is low, then it's safe to touch with your hand. But then again, we're not asleep. Why would we need to touch it anyway? All right, friends, that's all for this video. Thank you for watching. Goodbye.